Today I'm talking about 4 ways to represent a function. We have to define the function. The function f is a rule that assigns each element x in the set D. We have set D, and inside D we have element x assigned to exactly one element in set E. We have set E, and we assume the element y in set E. The assign means the mapping. The x is mapping to y. So this is called, we call this is mapping. This mapping satisfies two conditions. So it is called a function f. In order for mapping to become a function f, the mapping must satisfy a rule. A rule means two conditions. Two conditions are all elements in set D participate in mapping. And second condition is each element in set D assigned to only one element in set E. I will take an example. I take one example. We have different discrete elements in set X, X1, X2, X3, X4, and we have discrete elements in set Y, Y1, Y2, Y3, Y4. X1 is mapping to Y1. X1 is mapping to Y1. X2 is mapping to Y1. And X4 mapping to Y4. In this mapping, the X3 element doesn't participate in the mapping. So this is not function from X to Y. I'll take another example. Another example is the set X has a discrete element X1, X2, X3, X4. The set Y has element Y1, Y2, Y3. Now X1 is mapping to Y1. X2 mapping to S2. X2 is mapping to Y1. X3 is mapping to Y2. X4 is mapping to Y3. In this case, all elements in set X are participating in mapping, and so this mapping satisfies the first condition. How about second condition? Second condition is each element in set D. Each element is X1, X2, X3, X4. X1 is mapped only one element Y1. X2 is mapped only one element Y1. X3 is mapping to only one element Y2. X4 is mapping to only one element Y3. So this mapping is function because this mapping satisfies two conditions. This is function from X to Y. How about Y to X? So Y has discrete element Y1, Y2, Y3, and set X has discrete element X1, X2, X3, X4. Y1 is mapping X1 and X2. Y2 is mapping Y3. Y3 is mapping Y4. All elements in set Y participate in mapping. So this mapping satisfies first condition. How about second condition? This Y1 is mapping to two elements, not only one element. So this is another function. So this is another function from Y to X. So in summary, when the mapping satisfies two conditions A and B, it becomes the function. So we need to define some terminology. The domain is the set D. It's called domain. Like we take an example set X and set Y. The mapping is from X to Y. The discrete set X has discrete element X1, X2, X3, X4. And set Y has discrete element Y1, Y2, Y3. X1 is mapping Y1. X2 is mapping Y1. X3 is mapping Y2. X4 is mapping Y3. So this set X is called domain. And set Y is called range. The element in set X, the element in domain is called independent variable. Independent variables. The element in set y, element in range is called dependent variable. Dependent variables. And rule is two conditions. So the mapping, when mapping satisfies two conditions, it will be a function. So this is we start terminology: domain, range, independent variables, and dependent variables. So we I explain a function with discrete element, and when the element is continuous, we describe this function as a graph. So we sketch graph and find domain and range below curve. So this is first one, and second one, third one, and fourth one. And first is fx equal 2x minus 1. Generally describing graph, the horizontal axis is independent variable, and vertical axis represents dependent variable. So 2x minus 1 is that this function intersects minus 1 in the y-axis, minus 1, and the slope is 2. So this function intersects x-axis is 0 and 1 over 2. The graph is this. So this is the domain is minus infinite to infinite. It means x is greater than minus infinite and less than infinite. How about range? Range is also minus infinite to infinite. So we second graph is gx is x squared. This is horizontal axis is independent variable, and vertical axis represents dependent variable. So this is minus 1, 1, 1. The graph is like this, looks like this. So this, in this case, the domain is minus infinite to infinite. Range is minus y is not allowed, so the range is including 0 and infinite. This is y equals 0 and infinite. So this is domain and range. The third graph is fx. Third graph is fx equals square root x plus 2. And we can represent graph. X-axis represents the independent variable, and horizontal axis is dependent variable. So when x equals minus 2, it is 0. If x is less than minus 2, this is not defined because the inside square root is minus. It is not defined in real domain and range. So this is minus, the domain must be greater than minus 2, and when y equals 0, x minus 2, and when x equals 0, and this is square root 2. Square root 2, and this is graph is like this. This is graph. The domain is greater than minus 2, so this is minus 2 and infinite. And range is 0 to infinite. This is domain and range. The first graph is, this is gx is 1 over x squared minus x over 1 over x squared minus x is 1 over x multiply x minus 1. So x equals 0, x equals 1, and y equals 0. When x approach infinite and minus infinite, cx approach 0, so y equals 0 also asymptote. So this graph, we can throw, this graph is independent variable and this is dependent variable. The asymptote is x equals 0 and x equals 1, y equals 0. So we can graph this is like this. The graph this is a graph of gx. So in this case, domain is minus infinity to 0, minus infinity to 0, and 0 to 1, and 1 to infinity. This is domain. The range is except for minus between 0 and minus 4. So minus infinite and 4, and 0 and infinite. This is the range. So we can find the domain and range by the graph. And someone asked me, how can you draw this graph? I can draw this graph by hand or using TI-84 graphic calculator. I will explain TI-84 graphic calculator and try to draw this graph. So this is TI-84 graphical calculator. Graphical calculator. And the first you turn on, turn on the TI-84, and you can meet this display, and you push it to button, and you can push this button, y equal button, and you can find this display, and you have to input this formula. How to input this formula? And firstly, you can input as 1 and input this, and you can input x square. How to input x square? You can input this symbol is xt theta n. X is independent variable of function, and t is independent variable of parametric curve. Theta is independent variable of polar curve, and is independent variable of series. So you can set the independent variable in this mode, and default is function. So when you push this button, you can find the x on display. So x square is push this and this square. So this is x square minus push this again. This is x, and then you push this button. So you can express this formula on display at this screen. And after that, you can push this graph, and you can meet this graph. But this graph is not perfect. We need to adjust the window. So you push the window button, and you can change this value. This value I change. This is minus 8. The minimum value of x, maximum value of x is 8. The x scaling is this distance is I said this distance is 1, and the minimum value of y is minus 8 and 8 and 1. So you are cautious when you input the minus sign. If you want to express minus 8, you can push this button, not this button. So this button is express this is the minus sign, and 6 minus 8. You can push this, but you can if you want express minus sign, you have to push this button, not this button. So after adjusting the window and push again this graph, and you can find this graph. So the distance is 1, and this is 1, 2, 3, 4. This is minus 1, minus 2, minus 3, minus 4. So asymptote is y equals 0, and x equals 0, and x equals 1. So this is the same as the above graph. So you can graph by TI-84 graphical calculator. The next is how to represent a function. It means, for example, I ask someone what is the function of t. So someone answer me in 4 methods. First is the verbally. Just when I ask someone what is the function of t, the someone answered me in expression in word like this. When you turn on the hot water faucet, the temperature T of water depends on how long the water has been running. So it means independent variable is time and dependent variable is temperature. And draw the lap graph of T as a function of time the elapsed since faucet turns on. So someone express function by word. This is the first method to represent the function. And second method is when I ask someone what is function of t, of x, of anywhere, and someone answered me by table of value. It means someone give me the data. So for example, I ask someone what is the function of population, and someone give me the data, the table, like this, year and 1990, 1910, 1920, and so on, 2000. And at each year, we have a population like this. You can get this data from someone, and based on this data, we can draw the graph. This is year independent variable and dependent variable as population. The 1990, 1919, 1910, and 2000. And each discrete independent variable, we have dependent value like this. This is called a scattering plot. The second method is someone give me the data. The third one is by a graph. When I ask someone what is a function of t, the someone give me a graph. Function is, for example, this. For example, t and time and population, and this is like this. This is graph. Someone give me graph to represent a function. The last method is when I ask someone a function of some dependent variable, and someone give me the formula of the function. Function is y equal exponential x, y equal x plus 2, and so on. This is a very concrete method, right? So we have 4 methods to represent a function. I will take an example. The example is we represent a function by word, just expression. A rectangular storage container with open top. Open top is container is this container. We have this container, and a top is open. This is a container, and the volume is 10 cubic meter. Material cost for base per area. This area, the cost per area, $10. Its cost per area is $10, and material cost per area per side. This side, we have per side is $6. The length is 2w, and width is w, and the height is h. What is the total cost? This is the function of total cost. Total cost is base cost plus side cost. We can find base cost. Base cost is the base is the area of base is 2w multiplied w, 2w multiplied w, and the cost per area is $10. So this is 10, 20 w square, and side cost is the side is front side and back side. Front side and back side area is 2w multiply h. 2w multiply h multiply 2 plus the right side and the left side area is w multiply h. W multiply h multiply 2, and this cost per area is $6. So this is 4wh, 2wh, and 36wh. The total cost is 20w square plus 36wh. This is the answer for this question. But we have one more condition, the volume. The volume is 10 cubic meter. So this is volume is 2w multiply h, and 2w square h is 10. So we can delete one independent variable out of w and h. We delete the h. H is 10 over 2w square and 5 over w square. So we input h into the cost, and the cost is 20w square plus as 36w multiply 5 over w square. So this is 20w square plus 180 over w. This is the answer for this question. The total cost is 20w square plus 180 over w. So next topic is which rules define function. We discussed about the function where this is function or not in discrete elements. In this case, when element in domain and range are continuous, it's not discrete, how to check the function, whether this curve is function or not. The method is vertical line test. It means I will take an example. When independent variable and dependent variable are continuous, the function represents by a graph the independent variable and dependent variable, and the curve is like this. And vertical line test is, we draw the vertical line, and we check intersect. How many intersects exist? At this case, the vertical line test is the curve in the xy plane is the graph of function of x. This is function if and only if no vertical line intersect the curve more than once. The intersection is only one. This is function, right? This is only one intersection. This is a function. This is it function or not? This is a function. How about this example? This example is, this is x and y. Y and 0, and the curve is this. We draw vertical line. This has two intersects. So this is two intersection. So this is not function. The function has only one intersection. So this is not function. Only one intersection in domain range. So this is a 0 intersection, but this is not domain range. This is we cannot consider this vertical line, and we consider vertical line in the presence of domain range. How about next example is this is x-axis and this is y-axis, 0, and we consider the circle like this, and we draw vertical line, and this is two intersection. So this is not function. This is not a function. And how about this? This is independent variable, and this is dependent variable, and this is this curve. And we draw vertical line, and only one intersect. So this is function, right? So this is not function. This is function. So we check whether this curve is function or not by vertical line test. The next topic is piecewise defined function. What is a piecewise defined function? Piecewise defined function is functions which is defined by different formulas in different domain and different formula. I'll take an example. So fx is 1 minus x and x squared. Different formula and different domain. X is minus 1, x 1. When x is less than minus 1, the curve is 1 minus x. The x is greater than 1, the curve is x squared. When domain is different and formula is different, so this curve is called piecewise defined function. So we can describe this by graph in x and y. 0. This is minus 1. When minus 1 input this curve and is this 2. Minus 1 input this curve is 1. So this is a curve, and this is piecewise defined function. I'll take one more example. Example fx is after the value x. This is x or minus x. When x is greater than 0, this is x. When x is less than 0, this is minus x. This is x and y. 0 and y. And when x is greater than 0, this is x. When x is less than 0, this is minus x. Different domain and different formula. This is piecewise defined function. And we also define even and odd function. Even function, definition of even function is fx is f minus x. This is when we graph the even function, this graph is reflected by y-axis. The example of even function is a cosine function or polynomial function, n is even. The cosine function is x and y, and this is cosine function. This is reflected to y-axis. This is even function. And other function is f minus x is minus fx. This other function is reflected by origin. The example of odd function is sine function or polynomial, and n is odd. And we grab sine function is x and y. Sine function is like this. This is reflected by the origin. This is odd function. Odd function definition is f minus x equal minus fx. How about even and odd function, and each adding even and even odd and odd, and we don't need to memorize this. We can just put very simple function. For example, even function, we input x squared is 2x squared is also even function. X squared plus x, we don't know even or odd. Odd plus odd, we can input just x and x. 2x is odd function. Even, and we can input x squared and x to the power of 4. It's even function. X squared is input even and odd, and x squared multiply x is x cubic in odd function. Odd multiply odd, and x squared is even function. We can check this even and odd function just so we input the simple even and odd function. So next is increasing and decreasing function. Later we can check increasing and decreasing function by derivative, but at this time we just definition of increasing and decreasing function. And definition of increasing function is whenever x1, x2, and x2 when x2 is greater than x1, fx2 or fx2 is greater than fx1 for all x1 and x2. So decreasing function is whenever x1 is greater than x2, fx1 is less than fx2 for all real x1 and x2. I have an example. And how about this curve? This curve, and x2 is greater than x1, and fx1, and this is fx2. fx2 is greater than fx1. This is increasing function. So another example of increasing function is like this. This is x1, x2. This value is fx1. This value is fx2. x2 is greater than x1, and fx2 greater than fx1 for all x1 and x2. So this is increasing function. The example of decreasing curve is this curve. This is x1 and x2. x2 is greater than x1, and this is fx1. This is fx2, and x1 greater than fx2. This is decreasing function, and like this, and this is x1, x2, fx1, fx2. x2 is greater than x1, and then fx1 greater than fx2. So this is also decreasing function. How about this curve? This curve is, this is horizontal axis is, this is independent variable. Vertical axis represents dependent variable. So this is like this curve. This curve is, this is A and B. And this is, and from minus infinity to A. So x1, x2. x2 is greater than x1, and fx2, fx1. fx2 is greater than fx1. So this is increasing curve. From A to B is x1, x2, fx1, fx2. So x2 is greater than x1, but the fx2 is less than fx1. This is decreasing curve. And the range B from B to infinite. And this is x1, x2. x2 is greater than f1. and fx2 greater than fx1. This is the increasing curve. So we can check this curve, whether this curve is increasing or decreasing by definition. So today we're talking about the definition of function and how to check whether this is a function or not. And the one method is the vertical line test. And we also discuss about piecewise defined function, even and odd function, and increasing and decreasing function. Thanks for listening to this video, and see you next time. Bye bye.